Hi, welcome to my video on the inclination of a line. Inclination of a line. The inclination of a line is also called the angle of inclination when the line hits the x-axis. The definition: a measure of the angle from the positive position of the x-axis to the line. So I have a graph here. This is x and that's y. That's x and that's y. This is a positive line, this is the slope of this line is positive because it goes up to the right. And so if you go up, it's positive, to the right, it's positive. And the angle of inclination is the angle in the positive direction from the x-axis to the line. So this is the angle of inclination. Notice that the slope of this line is negative because you go up, which is positive, and go left, which is negative. Or you can go down, which is negative, and to the right, which is positive. So this line has a negative slope. The angle of inclination from the x-axis to the positive direction is there. That's the angle of inclination. So notice when the slope is positive, this angle is acute. And when the slope is negative, the angle of inclination is obtuse. So, to explain that a little bit further, let's draw a perpendicular from the line to the x-axis. So, if we let the rise be the y and the run be the x, then the tan of, if this is the angle of inclination and we call this angle theta, then the tan of theta is the opposite over the adjacent, which is the y over the x. The slope of the line is rise over run. So the rise on the line is the y, and the run is the x. So therefore, if tan is y over x and the slope is y over x, that means the tan of theta is the slope. But both of them are y over x. And if we have a line, which is y equals mx plus b, then we have that m is the slope and the b is the y-intercept. Then the tan of theta is equal to m, which is the slope of the line. So this is when you have an equation of a line and you solve it for y. In relation to the negative, in relation to the negative slope. So if you take this point, this is the perpendicular here. So if we go from here to here, that's a negative y, and you go this way is x. So the slope is the negative y over the x. Or you can also drop a perpendicular from here to here, and going this way, from this line, if you go from this point to this point, this x is positive to the right, this y is negative, so the slope is still the negative y over the x no matter what point. If you go from this point to this point, or if you go from this point to this point, the slope of this line is negative, and it will be an obtuse angle. Let's do some examples. Example 1. We have a line y equals a half x minus 1. So, let's draw the line. The slope of this line is 1/2. The y-intercept is negative 1. So the y-intercept is negative 1, which is right here. And the slope is 1/2. So we rise 1 and run 2. We rise 1 and we run 2. So if I draw a line through those points, then the slope of this line is 1/2. So that means the tan of theta is equal to the slope, m. So that means the tan of theta is equal to 1/2. So theta is equal to tan to the negative 1 of 1/2. And if you pick up your calculator, and there's my calculator, and I turn my calculator on and clear it. The inverse of tan, 2 1/2. 1/2 is 1 division 2. I could have called it 0.5. And my angle of inclination is 26.6. 27 degrees or 26.6. Let's say it's 26.6 to the nearest 10. That's my angle of inclination. Notice that this number, this is tan, and in relation to the inverse, tan is going from negative 90 to 0 to 90. And so because this number is positive number is here. So when the number is positive, the angle is between 0 and 90. So this angle of inclination is right here. So that angle of inclination is 26.6 degrees. A positive slope on the angle of inclination will give you an acute angle. Okay, let's continue. Let's do one this time which has a negative slope. So y equals negative 3/4 x plus 2. And the slope is negative 3/4, and the y-intercept is 2. So let's plot that line. The y-intercept is 2, so that's right there. 2 on the y-axis. We go down 3, right 4. Down 3, 1, 2, 3, right 4. 1, 2, 3, 4. So if I use a ruler and help me draw the line better. So this is the line that passes through the y-intercept. So that line has, again, notice it goes up to the left, so it's got a negative slope. So that means that the tan of theta is equal to the slope. So the tan of theta is equal to negative 3/4. So that means theta is tan to the negative 1 on 3/4. And again, repeat. So tan from negative 90 to 0 to 90, because this number is negative, negative is here, positive is here. Because the number is negative, then the angle is going to be between 0 and negative 90. So let's have a look at, clear it. So inverse tan of negative 3/4. So it's negative 3 division 4. Again, I could have called it a negative decimal 75. And that gives us an angle of 36.8, 30.86. So the angle is 36.9 to the nearest tenth. So it's, move the calculator, negative 36.9. Again, repeat, this number is negative, so its inverse is an angle between 0 and 90, so it's a negative 36.9. So notice that this angle that we're talking about is this one right here. This is the negative 36.9 coming down this way. But the angle of inclination is in the positive direction from the x-axis to the line. So we have 180. This is 180 degrees, and we take off the 36.9. So that gives us 36.9. So we have an angle of 143.1. So the angle of inclination is 143.1. 143.1 add on 36.9 gives you 180 degrees. Again, the angle is obtuse. Because the slope is negative, we'll have an obtuse angle. When the slope is positive, we'll have an acute angle. Okay, let's do some more examples. Find the inclination of the line, or find the angle of inclination. A, y equals 1/4 x minus 3. So we have the y-intercept is negative 3, which is right here. Okay, let's do this first. The slope is 1/4, and b is negative 3. So the y-intercept is negative 3. The slope is 1/4. So we'll rise 1 and run 4. 1, 2, 3, 4. And if you want, we can rise 1 again and run for 1, 2, 3, 4. So if I use my ruler and draw a line through those points, approximately right there. Okay, so the slope of this line, let's extend it further in relation to intercepting the x-axis. Okay, here we go. Unless the x-axis is coming out through here like this. So the angle of inclination is this angle right here. So the tan of theta is equal to the slope. So the tan of theta is 1/4. So that means that theta equals tan to the -1 of the 1/4. And let's use our calculator again. Put our calculator here, and we'll go inverse tan of 1/4, 1 division 4, and the angle is 14.0, so it's roughly 14 degrees. So the angle of inclination is 14 degrees. So that's the angle from the x-axis in the positive direction to the line. And again, because we have a positive slope, the angle is acute. Now we have another line, but we have to solve this line for y. So -5y equals 3x minus 10. We're solving the line for y equals mx plus b, so we divide by -5. They cancel, so we get y equals -3/5 x plus 2. So the slope of this line is the -3/5, and the y-intercept is 2. So let's have a look at it. So the y-intercept is 2, and we go -3/5 is down 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5. And we draw this line through those 2 points. And notice that the angle of inclination is this angle right here. It's the angle between the x-axis and the line in the positive direction. So let's see what the measure of that angle is. So tan of theta, theta is the angle of inclination, is equal to the slope. So that means the tan of theta is equal to -3/5. So theta equals tan to the -1 on the -3/5. And so what happens? Let's use our calculator again, because these are not us. Okay, let's clear it. Notice the fraction, these are fractions, so we have to use our calculator. If this is a half, or √3/2, or √2/2, or 1, then we'd be able to use the special right triangles. So inverse tan of -3 division 5, and we get theta to be, let's see, inverse tan, that looked like a wrong angle. So it's a -3 division 5. Now that's a -30, -31 to there's the nearest tenth. So this is bigger than 5, larger than 5, so -31. So the negative, move my calculator now, the -31 is this angle right here. So that's -31. Because again, if we look at right here, in relation to tan is between -90 and 90. When it's negative, is between 0 and -90. When it's positive, between 0 and 90. Because this is negative, the angle on the calculator comes out to be -31. -31 is this rotation here. So 180 minus the 31 gives you 149 degrees. So the angle of inclination, or the inclination of the line to the x-axis, is 149 degrees. Okay, let's continue. The more we do, the more we can understand what's happening. Now I have another problem, but just a little bit different. What about the angle of inclination between these 2 points? Well, first of all, let's plot the points. X is -1, y is 3. There's the point there. X is 1, y is -5. X is 1, y is -5. So there's the point there. So let's draw the line between. If I can find my ruler here now. It's just slipped away from me for a second. Gone up, I hope. Here we go. We're going to draw the line between those 2 points. So that's the line that passes through those 2 points. But now we can figure out the slope from the graph if we want, because we can go up and to the left, or we can go down and to the right. So if we want, we can go down. So that's 1, 2, 3, 4, 5, 6, 7, 8. So the rise is -8, and the run, so we go down and run 1, 2. So the slope is a -4. Let's see. Let's see if we have it right. Did I say 1, 2, 3, 4, 5, 6, 7, 8, and we go from 1 to a -1. Okay, here we go. Perfect, -4. Now, there's another way to figure out the slope. If we call this one x1, y1, this point is x2, y2. The slope of a line is the difference y2 minus y1 all over x2 minus x1. So that's a -5 minus 3, y2 minus y1, and x2, which is 1, minus x1, which is -1. So double negative is a positive, so that's -8 over 2. Again, we got a -4. So the tan of theta is -4. So that means that theta, let's go, got ahead of us up. The tan of theta is the slope of the line, and the slope is -4. So theta is tan to the -1, which is inverse of the -4. And let's use our calculator and see what we get. Clear that. So inverse tan of -4. And we have an angle that's 75.96. So roughly, the angle is 76 degrees. 76 degrees. This angle here, because it's negative, this is a -76. But the angle of inclination is from the x-axis to the line. So the angle of inclination is right here. So 180, subtract 76, the angle in inclination is 104. So this is 104. 104 and 76 is 180. And again, because it's negative, the angle for tan is negative. It's between 0 and -90, which makes sense. This angle is -76. So because the slope is negative, we have an obtuse angle. Okay, let's try another one that's a little bit different. Parallel to this line. Parallel to this line. So -4x plus 8y minus 8 equals 0. So let's solve this equation for y and see what the slope is going to be. Move the -4x so it'll become a positive. Okay, move the 8 over, it become positive, divide by 8. So we have y equals a half x plus 1. So, parallel to this line, so let's graph this line. The y-intercept is 1, which is here. So we will rise 1, run 2. Rise 1 and run 2. So let's draw a line going through these points. There it is. So this line intersects the x-axis here. So the slope of this line is 1/2. Y-intercept is 1. So the tan of theta is equal to 1/2. Now, parallel to this line. So if I draw a line, so this line has a slope, so no matter what intercept I take, so if I draw this line here, that's parallel to this one. So this line has a slope of 1/2. Any line that I draw parallel to this one will have a slope of 1/2. So whatever this slope is, the parallel line will have a slope of 1/2. So theta equals tan to the -1 of the 1/2. And that comes out to be, let's see, inverse tan, clear it, inverse tan of 1 division 2, and the angle comes out to be 26.56, 26.6. 26.6 degrees. So this is the angle of inclination of this line right here. So any line parallel to this one will have the same slope. So its angle of inclination will be the same angle of 26.6. And one more, what about the line perpendicular to this one? Well, perpendicular lines have negative reciprocal slopes, but we have to get the slope of this line first. So the LCD for 3 and 5 is 15. So I will multiply each part of this equation by 15. 3 into 15 goes 5, so that gives me negative 10x. 5 into 15 goes 3, plus 18y. And negative 6 times 15 is negative 90. I got to do, so I multiplied by the LCD, eliminate all the fractions. It's the easiest way. So 18y equals 10x minus 90. Divide by 18. Divide by 18. So y equals 2 into 10 goes 5. 2 into 18 goes 9. And 18 into 90 is negative 5. So we have a slope of this line is 5/9. The y-intercept is negative 5. But perpendicular lines have negative reciprocal slopes. So the slope of the line perpendicular to this one is going to be negative of it. So that's a positive, so it's going to be negative, and reciprocal. So it's the negative reciprocal. So let's illustrate that. Let's draw this. So we have a y-intercept of negative 5. 1, 2, 3, 4, right here. That's right there. That's the negative 5, right there. Okay? And the slope of this line is up 5, right 9. 1, 2, 3, 4, 5. 5, 6, 7, 8, 9. So I'm going to use a ruler so I can draw the line more accurate rather than use my hand because I got too far of a distance to go. So there's the line roughly between, that's the line that has a slope of, so notice that this is the angle of inclination here, but I want the line that's perpendicular to this. So if perpendicular lines, so let's take any line. So let's pretend that this line that I'm going to draw right now, this line is perpendicular, got a right angle. So that means if this line is 5/9, and perpendicular to it is a negative 9/5. So the angle of inclination is this line right here. The angle of inclination for this line, there's the angle of inclination for this line. So this is the slope we have to use. So the tan of theta is slope. So the tan of theta theta is a negative 9 over 5. So theta is tan to the negative 1 of negative 9 over 5. And let's use our calculator again to make sure. Let's go clear it first. Inverse tan. And we have negative 9 division 5. And that gives us an angle. So this angle is what theta is, but it's not the angle of inclination. It's 60.9 degrees. So let's remove this. So 60.9. So 60.9 is this angle right here. So this angle right here is a negative 60.9. But the angle of inclination is an obtuse angle. So 180 subtract 60.9. The angle is 119.1 degrees. So this is 119.1 degrees. Again, it's perpendicular to this line, so it has a negative reciprocal slope. And because this is a negative number, then the angle of inclination will be an obtuse angle. And the calculator will give you a negative angle because it's always in tan. Remember, tan goes from negative 90 to 0 to 90. It has restrictions. So the number is negative, you're between 0 and negative 90. The number is positive, you're between 0 and 90. So the angle of inclination of a line, hopefully that will explain it to you with many examples. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.